There was another very important phenomena about atoms that had to be taken into account. That is optical spectra. When light is passed through diffraction grating, a spectrum is produced. It was well known that atoms of different elements, when heated or placed in an electric discharge tube, have unique spectra. Each has a set of individual wavelengths or lines of color. So, for example, the spectrum in the middle of this page. When an electric potential is applied across both ends of a tube, like a Crookes tube containing, say, xenon gas, the xenon emits light with frequencies that are unique to xenon. And when this light is passed through diffraction grating, it produces the optical spectrum shown above. The Rutherford model had no explanation for this. Let's consider the simplest case, the atom of hydrogen. Its spectra had been well studied even before Thomson had discovered the electron. Here in the middle of this page, you can see a spectrum for hydrogen. In 1885, Johann Balmer formulated an expression for the experimental data that reproduced the visible hydrogen spectrum. In 1888, Johannes Redbirds generalized the equation to include the ultraviolet and infrared lines for hydrogen and all atoms missing all but one electron. Rydberg's equations exactly match the hydrogen spectral lines found by experiment. All the different series, that one discovered by Balmer, by Lyman, by Paschen, and so on. All of these had a very, very simple form, as you can see. 1 over the wavelength of the spectral line, 1 over lambda, is equal to r, a constant, known as the Rydberg constant, times the difference between the inverse squares of two integers. And Rydberg's constant was given by 1.0974 times 10 to the 7 per meter. In 1913, Niels Bohr applied Einstein's concept of quantization to the Rutherford model to explain the optical spectrum of atoms with only one electron. For example, hydrogen, helium that was missing one electron, lithium missing 2 electrons, and so on. Bohr's model agreed very well with the experimental data. In fact, his theory reproduced Rydberg's equation exactly.